search for it's the N diffusion contact. So it's called ND contact, N diffusion contact, right? I middle click on it and it tells me that it's too small. So it should be at least 4 by 4. So I do it again. So now I have a contact to metal 1. I'm gonna do another contact here. I'll just select it and copy it here. Oh, this is not symmetric. Okay. Oh, I think the minimum distance here is just 1 lambda between the contact and the channel. Let me see if I can
so now
increase it.
Now
no, it's not symmetric. Yeah. Yeah. So the contact there should be at least 1 lambda between the contact and the channel. So let me delete that. And what is that about? Okay. Okay, so I have an NMOS now. I'm gonna draw a ground line here. This is metal 1 and this is the ground line, and I'm gonna connect it here. Okay? Yep, this is the source. What's that?
It's not connected.
It is connected to ground. This is ground.
You're not in two different planes.
What's that?
The metal one and NMOS N diffusion metal are not in two different planes.
They are, but there's a contact here. So it goes. Yeah, it goes vertically down into the source, the diffusion.
Oh, so we don't do it.
This you did it. I just did it manually here.
Yeah.
The contact.
Yeah, but actually, when you draw the line between the contact and the ground, you just stop. This line stopped by the bottom of the contact. So as long as this is a top view of the 3D, so this line, the intermediate line between the ground and the contact should continue. Should overlap with the contact, or this is wrong, or
The contact reaches into the metal one.
oh yeah.
Okay.
Reaches
So the N diffusion metal just goes.
Yeah, it goes into the metal one. Yeah.
Can we have like two contact points above each other?
Yeah.
Like connecting.
If I want to connect this to metal 2, I would just place a metal 1, metal 2 contact, which is M1, M2. This is it. It's called M2 contact.
And we don't get any errors.
No, I can just middle click on it. Actually, the contact for metal 2 should be 5 by 5, so I got an error here.
Okay, so I have a question here.
Yeah.
You said that connection, connection 1. What do you call the first connect?
N diffusion.
Yeah, the one, the connection at the green, the left connection at the green.
Yeah.
You said it's by default connected to metal 1.
You connect it to whatever you want, but it's usually connected to metal 1.
Okay, so you said that we don't have to overlap the intermediate wire with the connection one with this square, whatever we call it.
You mean overlap?
Because metal one, we made a connection between. We made a connection to metal one, and this wire is connected to metal one. So that's why they're connected. So this means that if I make something like a connection between any other part of the circuit and the VDD, and VDD should be also
You lost me. Anyway, just follow along, and I'm sure most of your questions will get answered. Okay. So this is very incomplete now, and it has a lot of missing things, but I'm going to consider it done for the NMOS, and I'm going to go ahead and draw the PMOS. So first thing, I draw the N well, right? This is the N well. If it works.
What's the dimension?
Okay. The dimension. Okay. I'm gonna explain that later. Okay. Just for now, just follow along. Okay. So I made an N well. What am I gonna do now? The P diffusion, right? Okay. So this is the P diffusion. Like I said, it's brown. I don't know what that is, but okay. Like I said, there should be 6 lambdas between the boundaries. So I'm gonna go ahead and select it and move it up, and then make this bigger. Right? And I'm gonna make some poly. Okay. Do you guys remember that? Okay, just a second. Do you guys remember that I said the PMOS should be at least 2 times as wide as the NMOS because the mobility of the holes is not as strong as. Okay, so this is why I made the thickness of the PMOS twice as much. You notice the channel length is always the same. The thickness, which is the width, is double. So it's 8 lambdas. So for the NMOS it's 4, for the PMOS it's 8.
Also, because we have a law which concerns Z of the pull-up and Z of the pull-down, which is 4 to 1.
What's that?
I mean that there is like a ratio between the dimensions of the pull-up transistor to the dimensions of the pull-down transistor, which should be 4 to 1. We should maintain this.
4 to 1?
Yeah.
Don't you mean 2 to 1?
No, 4 to 1.
So the PMOS should be 4 times as big?
The pull-up in general. So if we
I've never heard of that before. I don't know. It might be true.
Nowadays we have 5 1.
Yeah, just ask Mazen. Anyways, and the convention of the contact, by the way, is to take all of the width. So here I'm gonna increase the size to this, and same here. The contact here, what contact should I use? It's P diffusion metal 1, right? So I search for it, that's it, PD contact. PD contact. I have a PMOS. I'm not gonna connect anything yet, except I'm gonna connect the 2 gates together for an inverter. Yeah.
Can we please just try to put another contact point on top of the first one created and try to connect, for example, ground to it or whatever, just see how it distinguishes, between 2 contacts.
Oh, okay. Okay. So
The program behavior.
So let's assume we have a metal 2 line here. So I go to metal 2, which is this purple. Okay. So here I have a metal 2 wire crossing above a metal 1.
Yeah.
They're not touching because each one is on a different horizontal plane.
So if they're touching, you find that
If you want to touch them together, connect them here, you place an M1 and a metal 2 contact. and you make it bigger.